Hey everybody, this is Mr. Mott. What I want to do is give you some notes on periodic trends. Okay, appreciate you guys taking the time out of your evening to do this. We haven't quite been able to catch up, so maybe we'll make this bonus here. All right, anyway, here we go. So what we're going to talk about is periodic trends in our periodic table. So trends are going to be things that are going to be increasing or decreasing, and the main thing I want to focus on is like the atomic size. Okay. So the trend in atomic size, let me see if I can flip over to see if this works here. All right, it is not working. Okay, so the periodic trend size, basically in a nutshell, your largest element is going to be francium down here. This is going to be like your largest element, okay? So we know that the protons, neutrons, and electrons are a part of the atom, right? So the electrons, in this case, are really far outside of the nucleus. Okay, they're so far out of the nucleus that they're also very easy to remove. Okay, we're going to come back to that. Now, your smallest element is going to be up here. It's going to be up here at helium. Okay, that's going to be your smallest element. Okay, so your trend in the periodic size. And you can think about this a few different ways, but your trend in the periodic size is going to be, it gets bigger as you go down and to the left, okay? So that's going to be one of our trends. So you can either write this kind of in the middle, or you can kind of go this way, okay? So we say atomic size, or you can say atomic radius increases. Okay, this way. All right. Now, the size really has big implications in terms of the how it reacts. Okay, so maybe you remember from when we in the language unit we talked about metals. We said metals are losers. Okay, so first of all, your metals are going to be separated according to this staircase. Okay, and so this staircase acts as kind of a separator for your metals and your nonmetals. So your nonmetals are going to be up here, and your metals are basically everything to the left of your staircase. Along the staircase, you have metalloids, and the metalloids have characteristics of both metals and nonmetals. For instance, metalloids can be conductive, or excuse me, metals. All metals have the properties of being conductive. They're going to have a luster, which means that light kind of reflects off them. They're malleable. You hit them with a hammer, and they'll flatten out into a sheet. They're ductile. You can draw them into a wire. Nonmetals are pretty much opposite of that. So nonmetals are going to be brittle. They're going to be not conductive or non-conductive. They're not going to be shiny and have a luster, and you can't make them into wires or sheets. Okay, so your metalloids are generally located along the staircase, and they're not necessarily all the elements along here. It happens. You have to determine whether something is a metal, non-metal, or metalloid based upon their properties. So if they have a mixture of those properties, then it's going to be called a metalloid. Okay, so anyway, let's get back to the trends. Okay, so when you have really, really big atoms like you do down to the left, it's very easy for them to lose electrons. Okay, that makes them very, very reactive. So along this here, what we can also write, since the atom gets bigger, let's go ahead and write that the metal reactivity increases. Now, your nonmetals, their reactivity is a little different because of electronegativity. You have really, really small elements like fluorine, the most electronegative element, and this one, since it's more electronegative, has a really, really strong pull on the electrons. And so this is your nonmetal reactivity increases here. So we're going to draw an arrow here. We're going to say nonmetal reactivity. increases this way because of the electronegativity. Okay? So a lot of these have to do with the atomic size. What we can do in class is talk about why does the atomic size increase as you go down. Okay, that makes a lot of sense because the atom has a lot more protons and neutrons and electrons as you go down, but the atomic size actually decreases to the right. And that's a little bit of an anomaly and has to do with where the electrons are in terms of their energy levels. All right? Thanks for watching, guys. If you can come into class with this ready, we're going to be ahead of the game, and we'll throw a couple bonus stamps at you. Thanks very much.